Okay, my friends, this should be interesting. This, as you know, is a photon, shown it a million times. It's two electrons back to back, just like bar magnets. We are able to separate them when we approach the Venturi and explode them into their separate particles, as I'll show you uno momento. And this is the leading part that concusses glowing additionally to the other. Now, let's see what CERN would like to see for muons and electron showers. Muon neutrino, which is the black ball, attached to an electron neutrino, which was the white ball, separate when they go into what's called Cherenkov radiation. I agree. The muon goes on its way, the electron creates showers, and then it's instantaneously reattached. Can I show you that? Absolutely. Okay, 6 years, minimum 100 videos about this. This is light, which is a magnetic particle I just showed you way back here, and the field surrounding it is magnetic field. It concusses with all the particles that are in the air. When we put it through a Venturi, the field and the particle accelerated. Well, the field couldn't catch up with the particle, so the particle left the field. And here it exploded here. So we know we can accelerate light. We now know that it's a particle with a field around it, and I can show that in many, many ways. Now we also know that we can separate the black from the white, which is the photon, which is right there. They show up just as they concuss at the Venturi, and you see the black and white ball attached back and forth, which is a muon neutrino and the electron neutrino, and then the white ball creates showers. The black ball gets out of the way. And can you show me that, Roger? Absolutely. And here it is, my good friend. That was the Venturi. That's where it concussed. There's where the spray of white electron neutrino showers, electron neutrino turns into electron showers. Yep, I agree. The muon gets out of the way? Yep, I agree. The muon is gravity? Yep, I agree. It reattaches back here instantly after the Venturi? Yep, I agree. It is dark matter? Yep, I agree. Only they don't say that. They need to agree with me. It is the muon? Yep, I agree. That's what we got here. And that is, to me, right now, the black is gravity, it's muon, it's dark matter, it doesn't emit, it doesn't absorb, it doesn't concuss. All it wants to do in life is to suck back the white particles. And then it will form a central core, and the white particles will surround it. That's what's called atoms. Very, very simple. Red laser pulsed through two round Venturi pins, forcing everything to go into that. It's really right on top of the pins, actually. And then it sprays all of that stuff out the other side. And they say it's 200 times increased energy from what we started with, if you can get them to separate into their bosons and, fermions and all that kind of things that they call them. And we can, obviously we can. So what do we need to do? Put a harvest plate right here before they reattach and take that energy, because it's extreme amount of energy. It's going to force its way through whatever you need to put it into, a dielectric, so that it's captured in, I say dielectric, I don't know what to do with it, but somebody smarter than me is going to be able to figure out how to harvest this. Right now you use solar collectors, almost the same thing. Now you might have to have them on steroids, I don't know. But they have to be extremely close, because this distance is like really almost nothing. It's extremely, magnified. Okay, I am claiming we did nuclear atomic photonic fission and created basically the same thing that would be a nuclear bomb. And you say, oh, come on, Roger, how could you do that? Well, here's how we did it. You remember that wave coming this way, boom, 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 and now it all of a sudden accelerated like a rocket ship, and the particle was in it, which I showed you 1,000 times, and the particle separates into the black and white and explodes here. Well, guess what? That's exactly an atomic bomb. And you say, no, come on. And I say, yes. And you say, well, how can you show me it's an atomic bomb? I say, you ever see a shock wave from an atomic bomb? Here it is right here. These fields are being so accelerated because it's shocking back. And look at that shock wave. Look at that. That's the shock wave coming back from the impact. All right, we have accelerated this particle and created an extreme interaction and explosion. Now, why can't we use that nuclear fission? And which it is. It's all it is fission. You see the black and the white separate, no question whatsoever, which means fission. And this is subatomic, which means we're in the atomic realm, which is lower than the nucleus. So we are really in fission of photons, creating so much energetic reaction. It's literally an atomic bomb on a desktop. And if we did it right, with the powerful enough lasers, we should be able to harvest free energy. I'm not sure I showed you this yet or not, but that is the green, as it does the same thing, concusses, but it concusses further out and then gets sucked through the Venturi and vaporizes basically into its black matter, which is behind, if you can see, and the white is what energizes out, is what we see. Okay, I've done a ton of videos on this, and I just did a ton of clips, so I'm just going to put them all, batch them together, and do another video to try to explain all of the nuance. But what did I just show you? I showed you light in a pulse red laser accelerating particles that precede it as it forces its way through the particles that are in its environment. I saw the wave accelerating and the particle literally leaving the wave, concussing, separating, dividing into its constituent components, the black and the white ball, the muon neutrino, electron neutrino turns into an electron shower, the muon just goes on its way. The Higgs fields, the distance between the accelerator and the Higgs fields here, we can harvest our energy here, is what I'm hoping. These are the electrons. Well, there are two electrons back to back, create a photon. That is something, who knows what. Blue particle, a little too hard to see. Now, I think this warrants at least some examination. After showing you these reverse particle waves, it's just like an atomic bomb going on.